Recently, I have bought a sensor expansion board for STM32Nucleo. This is the latest version of sensor evaluation board released by ST. It is called X-Nucleo-IKS01A3. It contains various latest sensors from the ST, such as the accelerometers, gyroscope, magnetometer, humidity, temperature, and pressure sensors. It comes with Arduino Uno connectors for attachment to Arduino Uno and any Nucleo boards. I've stacked the sensor board onto my Nucleo board in this manner. The Nucleo board that I'm using is the Unicleo F411RE. It can be easily purchased from any local distributors. I've been using the Cal Microvision IDE for all my previous STM32 projects, but recently I've downloaded and installed STM32CubeIDE, which I feel that it provides a very complete development platform for the STM32 with all the necessary tools integrated into a single IDE environment. So in this video, I will first show you where to download and how to install the STM32CubeIDE. Then I'll proceed with the getting started with X-Nucleo-IKS01A3 board. So you can go to your web browser and search in the Google for STM32CubeIDE. You just need to install two software from ST to run the IDE. If you need extra software packages, it will prompt you for download and install while you're using the IDE itself. Because the IDE is built upon the Eclipse IDE, so you will not face any issue if you are familiar with the Eclipse. Once you are in the ST website, click on Get Software and select the software for your operating system. So for mine it's a Windows, and I will get the latest version. Before you can download any software from the ST, you have to register for an account. I will place the installation file on my desktop for easy access. I'll create a folder called ST. The next software that you need to download is the STSW Link 009. This is a PC driver to connect the physical ST link to your PC via the USB interface. You just need these two software in order to run the STM32CubeIDE. But I will also download and install another application. So you search for Unicleo GUI. This is a graphical user interface that can be used to read the data from the sensor board that will be used near the end of this video. I will unzip all the downloaded files. I'll install the Link 009 first. I'm using the 64-bit operating system. I select the AMD 64. Okay, next I will install the IDE itself. I'll place this in the program files. With a folder ST. And lastly, I will install the Unicleo GUI. Okay, and that's it. You have installed all the necessary software tools for the STM32. So I'll proceed with getting started with X-Nucleo-IKS01A3. Open the STM32CubeIDE by typing STM32, and you can see the application here. Click on File, New STM32 Project. I will select my board. Since I'm using the F411, so I select the Unicleo F411RE, click and next. I give a name called Data Fusion. We have to configure a few parameters in order for the sensor board to work. The board that I have does not have a high-speed clock, so I will disable. And we'll set the I2C communication at the PB8 and 9. Go to the connectivity and click on I2C1 and select I2C. Change the speed mode to fast mode. Next is the UART connection between the STM32 to your PC. So we're going to use the PA2 and PA3. Click on enable the global interrupt. Under the DMA settings, we have to add the receive, and the mode is circular. For the baud rate, we have to change this to 921600 so that it can talk to the Unicleo GUI that we'll be using near the end of the video. The software also needs to use the timer, so for our case we'll be using the timer 3. Select the clock source, internal clock, and enable the timer 3 global interrupt. Turn on the computing CRC. Next, we have to download the software package. So click on the software packs and manage software packs. Click on the ST Microelectronics. Scroll down and you will see the MEMS. Select the latest version and install. After you install, you go to the same software packs and select components. Go down and you'll see the MEMS1. When you expand, you'll see that you got the device, board part, and board support custom. So the board offers various configurations. We can use the example code given by the package by selecting the device and the application. There are many applications that you can choose, and the source code will be automatically generated. The board part and the libraries will also be automatically selected below. Or you can select by the component from here to here. For example, you need the accelerated magnetometer or the accelerometer gyroscope. And then select the necessary parts that you want to connect using either the I2C or the SPI. And then the libraries will automatically selected for you. As this is a getting started video, I'll be using the example code provided by the package, and all the components and libraries will be selected for me. After the source code are auto-generated, I can modify according to my requirements. I believe that this way is an easier way to quickly develop your application, but please take note of its software licensing policy. Okay, so under the application, I will select Data Fusion. Now you notice there's a alert icon appear. Click on this, and you click on the resolve, and you see that click on the last part, show, and you need the RTC. Click on OK. Go back to your pin configuration, click on the timer and click on RTC. Click on activate clock source and the calendar. Go back to the select component again and make sure that the application is marked with a green check icon. So it means that all conditions are solved. So in this data log fusion application, it will collect the magnetometer, accelerometer, and gyroscope data and output the yaw, pitch, and roll in degrees, linear acceleration for the 3 axes in G's, and the quaternions data. These are very essential for autonomous vehicles and drones. And then select the software packs. Click on the ST Microelectronics and select all the 3 selection here. So we have to match the resources to the required function here. I'm going to use the telemetry for a timer, the blue push button for the BSP button, USAT will be USAT2, I2C1, and the green LED. Once you're done, click on the Save button. You can find your codes under the core, source code, and domain is over here. And sensor board libraries will be under the MEMS. You can see under the application specific and the target boards. Okay, the target sensors. Click on the compile. Ensure that there's no error. Okay, notice that the default application do have an error. So it's double click on the error. It says that the implicit declaration of the function mx timer 3 init, did you mean mx ms init? So what happens is that this function, if you open the declarations, it's in a main and it was declared as a static. So we remove this and we have to move the declaration here to the main dot header. So the header will be located at the include main.h. Click on the compile again. Make sure there's no more error. Okay, click on the run arrow and run configurations. Right click on the application, new configuration, use the default and run. Okay, I have not powered up my STM Nucleo board. So what I do is that I'll attach the USB cable between the Nucleo boards to my PC. Okay, I'll click on the data fusion debug again. So it shows that download verification successfully, shutting down and exit. Now I can close my IDE and open my Unicleo GUI. Once you open that, you can see the COM. Make sure you select the correct COM port. Click on the connect and you'll see the options for the IKS01A3. So you can either disable all the sensors or enable all the sensors. and click on the user message, click on the start, and make sure that all the data are displayed here. So what you have is the accelerometer, gyroscope, and the magnetometer raw data with the continuance information and the yaw pitch row, and also the linear acceleration XYZ axis. You can click on the fusion button here and you'll see a port simulation. So when I move my STM board, you can see the rotation. Okay, click on the 6 sensor fusion. Sensor fusion 6x refers to using the gyroscope and the accelerometer. If you use the sensor fusion 9x, you will be using magnetometer, accelerometer, and the gyroscope. Okay, so that's the end of today's video.